So, on about 50-ish minutes or so, what can we get done in 50 minutes? All right, so let's focus more on this, the idea of this workspace index repo commit, because that's something you're just going to use all the time. So I mean, you saw as soon as I started doing anything with Git, I started messing with it. So let's go back to where we were before. This is, by the way, is a nice Linux shortcut. If you say cd space dash, it just goes to the previous directory you were in. It's just a toggle. It doesn't remember any further back than that. It just goes back and forth. If I do it again, I'm here. And so, but sometimes it's handy if you remember that you haven't gone anywhere else. So here we are. So let's spend a few minutes. I want to dig around a bit in the Git repo directory, that .git place. But to do that, we're going to need to run one command here to make sure that that is what I want to do. Yes. So let's say I'll run it first. If it works, you guys can run it too. Okay. So run, assuming you're in the learning-git-chris directory, go ahead and run /loose-objects.sh. And I'll tell you what that did. You only need to run it once. So to avoid any mystery, here's the shell script that is. So okay, put this in the bucket of something you don't really need to know very much about, but I'll tell you anyway. When you push up to GitHub.com, you push all these SHAs that we've been talking about, the commit SHA, the tree SHA, the blobs, the some references, branch references, etc. And then GitHub makes use of one of these magic Git commands that of which there are thousands, and it compresses what you've pushed up there, and it kind of cleans it up. So if you've like changed a branch, there are cases where you'll start out somewhere and then you'll just change your mind and just back off, and those SHAs don't necessarily go away. That's important to know. Unless you take them away, they're still there. You could put the branch back onto that SHA, and it all comes back and shows up in your ADOG, and you're good to go again. But when you push it up to Git says, well, hey, there's nothing referencing these SHAs. I'm just going to clean them up and throw them away because they're taking up space. So I'm gonna just make it much smaller, as small as I can. So it does that. It also does a pack operation, which compresses it even further. So then when you pull your stuff back down, it's not necessary. It looks the same as far as all these commands that we've been running, but underneath the hood, it's all packed, and it doesn't, it doesn't look it's not as visible. So you can see a little bit of this by what I just did here in my terminal session. Normally, all those SHAs are stored in .git/objects, but when I did it this time, they weren't there. There was just these info directories and pack directories. And so I said, there's nothing, it's all packed, it's all compressed. I can't see what I want to see. So I ran this script, which has other magic Git commands like git unpack objects. And it basically pulls out all that stuff back out and puts it where it was when I started to do my Git operations. And so when I ran it here, and then I looked at it again, the exact same place, now there's all these basically directories that contain these SHAs we've been talking about. So it just helps us to look at things from a teaching point of view. It doesn't actually change our Git repo or the way it operates. So just so you know, there's no deep mystery there. It's just shell scripts and git commands. But if we want to do something like look at where our head actually lives, we can say, what can we say to see where our head is? Any volunteers? What SHA are we pointing at? How do you see that?
Git checkout.
Okay, that could change your SHA. We may not want to do that. We just want to see which one it is. You certainly would know after you do that because it'll tell you, but you may not like the result. Okay, that'll do it. Okay, so here's this shorthand for that SHA. Okay, so I'm going to quit. So let's go find out where that thing actually is. I mean, we can do this, right? We can use a command to see it, but that doesn't tell us where it actually is in the file system. So let's go hunting. So we're in our .git directory, and we've looked at head already. We've looked at, in refs, there's some stuff. Oops, refs. It's organized into local refs, which is under the heads. We can see some stuff we recognize in there. Just master right now because we've only got one branch. We've looked at remotes, which has our remote refs. And because you can have more than one remote, we have to go another level down. Okay. So now this objects directory, though. So this is getting right down to where these things are at. I've copied my SHA just to keep it track of what it is. So that's where it starts with. You can also file this in things you don't really need to know, but this directory is organized basically by the first two letters of the SHA, and then the rest of the SHA is the actual content. So, for instance, there should be a directory called 1.8 here somewhere, and there's not. Uh-oh. Why would that be? Did I mistype it? No. Didn't mistype it. Could also be that my pack didn't work the way I thought it should. And no, it's because I'm not in objects, that's why. Okay. Got lost in the matrix there for a minute. All right, so assuming I'm in the objects directory, I should be able to CD to 1.8. Phew, okay. Will make sense again. So now, here are all the SHAs that start with 1.8, right? That's just how Git organizes things. So our SHA is 1894B26, which would be this one. So let's see what kind of thing that is. Okay, it really basically doesn't know what it is. It's taking a guess, and it's guessed wrong. But that's what Mac OS thinks it is if I ask it. So it's actually a compressed version of this blob, right? That actually not a blob. Sorry, it's a commit, isn't it? So this came from our ADOG. So the commit is actually this content here, and because it's mostly text, you can compress it quite a bit. So this thing is only about 178 bytes, in this file. Whereas if we did a git cat file on that, it would turn out to be a lot bigger, I'll bet. Oops, I got to be out of still doesn't work because I forgot -P. Well, this is not that large, but it's certainly larger than 178 bytes. So there's some compression going on. And so you can kind of, see that what cat file does is uncompress it and show it to you as it really was before it squeezed it on down. But the idea is that all these objects are down in here in .git. This is where all of your SHAs go to live. This is the when you say it's content addressable, the address is resolved to these contents down here.
Can you PWD that real quick? I just want to
Sure.
see what's happening.
Yeah, so here's our repo root right here. So I've gone down inside of the .git/objects directory to poke around a little bit and see where all those shells actually are. So yeah, not much more to see there, but that's where they are. That's what you're doing when you do a git checkout. It just goes down in there and stitches everything together and pulls it out and puts it in the arrangement that your commit, tree, and blob architecture determines, right? Dictates. So, alrighty. So anyway, back to. Is there anything else you want to look at here before we leave the .git directory? Not much. There's not much more to it. There's there's a hooks directory that you can use to attach stuff to do when a particular action happens. If you want to maybe before you commit, have it run to see that you've got you don't have any lines that have spaces at the end of them. You can have that run and then turn back your commit if it finds any. So you can look up hooks and put cool stuff like that in there. But it's not necessary to use Git effectively. I guess config. What's in config? That just stores stuff that you do when you say git remote add or git clone, or you can add some stuff manually as well. But this is where a lot of the config lives for Git, and you can it's fine to change it explicitly if you know what you're doing. You can just go right in there and pick stuff up if you find it easier than trying to remember the git command that does it. So .git/config. All right. Let's go look at workspace index and commit a little more closely. So part of what I want you to do here is get comfortable changing things. Is so you can try stuff and get back, return to where you were if you screw it up, because you're going to screw it up. So knowing how Git's put together helps you to recover. So let's go screw something up. We got, say we're here, and let's say we wanted to make a check-in and change our mind and just return to where we were before. So let's VI something or edit something or subble something, whatever you want to do. Take a file, make some change to it. This will be a syntax error if I run it. So there's my change. Sure, that'll work. So now, what state are we in? How do we tell what state we're in?
Git status.
Okay, excellent. Git status or GS. Let me run that again to get us. So what is it telling me?
Hasn't been committed yet.
Change is not staged for commit. Right, it hasn't been committed, but it also hasn't been staged. So it's in this world of these three trees, it's just in the workspace. It's not in the index yet, because otherwise it would say that it's staged. How do I stage it? GA, right. And I have to tell it something. I'll just tell it dot, and it'll just stage everything that hasn't been staged that could be staged. And then I'll run GS again. Now it still says modify, but now it's in green, and now it says, instead of saying not staged, now it says it's to be committed. So it's been sort of promoted into this index, right? And also if I say git diff, now it doesn't show any diffs, because diff just says, as you recall, difference between the index and what's in my workspace. I can say GDS for git diff -- staged, and now that's looking one level over, right? It's between index and commit, not between workspace and index. So I do that a lot. Just look at those two kinds of diffs. So I'm saying, okay, that looks good. I'm going to commit it. And just put it in there. Okay, it says good. This is the SHA I've computed for that commit. There you go. Look at A-dog. Okay, so there's the excellent commit. And what did I actually? I just run this. So if I run /test.h, what happens? Well, that's a different problem. Anyway, let's suppose I realize that was a terrible commit. That was not excellent at all. How do I get back to where I want to be? How would you do that? I mean, this is earlier in your commit history. I'm sure this has never happened to you yet, but it will. How would you get back and just throw away what you just did safely and return to things as they were before? I mean, it's a worthy goal, right? I don't think you have to argue that point.
So am I trying to pull the latest commit, or am I?
Well, this is where you got to, right? This is where we were.
Yeah, maybe start there again.
How do you get back to there? That's the question before us.
It should be stored as one of the objects.
Right. Yeah, it's still stored there. Partly because you've got other pointers that point to it, so it's going to show up on your A-dog. As long as there's a pointer pointing to a commit, it will show up in your A-dog history. So let's try this thing. Have you guys used get reset at all? Okay, this is one of the things to write down. This is a keeper. So there's three get resets that are commonly used, and they correspond to these three trees as far as what they do. So it's --soft, --mixed, and --hard. So I'm going to show you them out of order. First, we're going to look at --hard. So the state that we're in now. If we say, I'm going to Control-C that. I'm going to say, get status. So what it says is, it says nothing to commit, comma, working tree cleaning, right? So what does that tell us about our three trees with respect to their state with respect to each other?
That's it.
Right, exactly. They're all the same. Nothing's out of order. We're all, the commit is the same as the index, is the same as our checked out tree. Okay. So let's go back to that get reset --hard. So get reset takes, besides the hard mixed soft option, it takes a commit. So your commit can be like the exact SHA. It can be a reference to the SHA. Which I don't have actually that reference before me, so I can't give it the exact SHA because I forgot, because my memory is very short. So what I can do though is I can say, give me not head. I don't want to point it to head because I'm already pointing at head, but give me the thing that head points to. Give me head's parent. So that's what that syntax says there. Head caret sign. Take my head and move it back to whatever the parent is. And not only that, because I've said hard, do the same with the index and do the same with my workspace. So it just changes it all. Okay. So it tells me what it did. Now we may recognize it SHA because we've been playing with it before. And we look at our A-dog now. Now we're back, right? Now we're lined up with origin master again, and now our our test.sh is what it used to be, and we're all as we were before. So what about that other commit? What if we wanted to go back to it? We thought, you know what? There's some stuff I need from that other commit. I didn't quite want to throw it all away. What if I wanted to go back to that other commit? Is it still there somewhere? Yeah, because it's Git, and we haven't done a prune or any of the pack stuff, or it's still there somewhere. Unless we take actions explicitly to remove it and prune our whole repository, it's going to be there. Anybody remember what it was?
18 or something.
I don't remember what it was. Here's a command that you probably won't need to know very much, but sometimes comes in handy. So ref log is short for reference log. This is stuff that you've done locally. All right, you don't push this up. It doesn't go anywhere else. It's just on your local repo. But it's kind of it's a log of what you've done and where head used to point, basically. We haven't done much, so it's only three lines long, but it's enough to tell us this, right? Here's that thing that we used to, we tried and it wasn't quite good, but let's go back to it anyway because it wasn't completely bad. So I'm going to copy that and get out of here. Now we have a couple of options here. We can do a reset hard again and just go back where we were, or if we just want to look at it, we could just check it out directly. Right? You can just do that, and you get a bunch of stuff that you have to read through, but it does it for you. It says it did this, but it also says you're in detached head state. So what in the world does that mean? It kind of tells you. You look around. You can see what's there.
You need to plug up.
Oh wow! I guess the screen uses stuff, doesn't it?
Real fast.
Is there a plug here? I've got one if I need one. Okay, pause just a minute. Oh, wow. Grab some power. Is there a plug? Oh, that will not work. This will work. Does that go anywhere?
Yeah. Yeah. Here, I got it back here. Need to share these. Mike, give it up.
We've got a few minutes. Is that going to go anywhere? Or, how about this one right here? We'll plug into that one. Can we just flip this one off for a minute? That should unplug from right there.
Try this. Oh, you got it?
Right there. There we go.
Yeah.
All right.
Right on. This command.
Oh, good.
That's yours.
Thank you. Awesome. Thank you, guys. So remember when we looked at that head file and it had that reference, refs heads master on it. So if we do that again, let's see what it is. That basically is what detached head means. It's no longer a reference. It's not, there's not a pointer. You look at the ADOG, notice now it just says there's head and there's no arrow symbol there anymore, right? It's just, you're just at that commit. It's, you can't it's not a branch. You're not on a branch anymore. You're pointing directly at that commit instead of through this branch reference. So there's things you can't do if you're in that state. You can look around, but that's what it's telling you. You can't quite do everything you would do if you were doing things the sort of customary branch-oriented way. So that's, it's okay. You just, as long as you know that's where you are and that's what's going on, right? We can see our we can see our changes that, you know, that had this bad line in it. And if there's anything we want to get out of there, we can see what, you know, what we want to see there and take it with us. So that's one option. Another option is to, you know, do that git reset and put ourselves back there just the way we were before. So instead of saying git checkout, we could do that reset -hard again. Right? And then it looks like it did before. You know, it doesn't. That's weird.
You had the 07B. I don't know if like you meant to, but that's
well, I would thought it would. Okay, so that's interesting. It doesn't actually associate it with the branch. Notice our, you know, we used to have master here. So if we go here, what's that do? Okay, that takes us back here. So now we're on.
Do with the carrot thing.
That's interesting. The reset -hard doesn't actually take us back to a branch, does it? It knows about master because master is this, but we're still not actually on master. We're still detached head state, aren't we? Right? If we do a git status, it says your head is detached. So now we can go back to master anytime we want to by just doing this. Now it all makes sense again. Now if I run this, I predict what will happen is at this point, since we're already on a branch, it'll just move master along with us. Let's see if that happens. Okay, yeah, so now we're still at master, but now we're also here at this excellent commit. So now we've got the symbolic reference back, right? That's what we wanted in order for us to be able to continue to check out. So I learned something here. But you can, I hope you can see that if you know where you're supposed to be, you know a little bit about like head being a symbolic reference. You know that you're in a place that makes sense when you see that. And if you don't see that, then you've got some work to do to figure out how to get back there, so that you can do more checkouts, and you're not going to be in this detached head state where you can only look at stuff and you can't actually change anything. Right? So we're looking at different ways to manipulate our index and what happens. So far we've looked at git reset -hard, which just changes everything. Let's look at one more option to kind of look back at this commit here. So before I do that, I'm going to put us back where we were before, which can be this you know, head caret thing. That's where we were before. Another option for keeping track of that branch that we don't necessarily want to be on, but we want to look at. This is another key. This has to do with like what branches are. So what if we just made that a branch? How would we do that? What would have to be the case? What would have to be in place in order for this to be a branch? This bad commit that we've got.
Would you just create another branch and pull it in there?
Okay. Yeah. Git branch. What do you want to call it? Excellent comment.
Excellent.
Excellent. So is that what we need to do? Just that?
Oh, -B.
-B?
Or after branch.
Oh, like dash here, over here?
Does it get checkout?
So you could do a couple, yeah. If you did git checkout, -B, that checks you out and puts you there. If you just branch, it creates it and doesn't move you anywhere.
Okay, so.
Okay. What we wanted to do? Yeah, I mean, we've got a branch, but it's actually pointing to the place we already were. So what if we wanted to point it to the place that we, you know, this guy up here? Go back to master. COM, I'll use my for a moment, and let's walk back that change for the moment, so we can branch -D to get rid of it, right? Okay, deleted. So what you can do with branch is give it an arbitrary commit. So we could just say 07B838. Now notice we did that. We're still a master, but now this thing has reappeared on our history because now there's a pointer to it. Now there's a branch pointing to it, right? And the A in ADOG stands for -- all. So we're telling Git show us all branches that are in our repo. So now it reappears for us, and we can check out there if we want, right? Now we're on that branch, and now we're a little better off maybe because now if we do want to continue from there, now we've got an actual branch that we can commit to, and all that. So it's just another option. But I think one of the points to take away here is that a branch is just a file with a commit SHA in it. That's all it is. And on all these git branch commands we run, just manipulate this file and put different commit SHAs in it, so that Git can show them to you in a way that you want to see them. You could put a branch at any arbitrary place on this graph. Pick one. Branch, arbitrary, SHA. Now you've got a branch. Right? Now you can check out, commit to it, merge to it, merge from it. Anything you do with the branch, but it's just a pointer to some SHA, and it's up to you what you do. Up to you what you do with it. So knowing that, I hope it helps you see you can get back to where you need to be, for one, and you can find your stuff if you think you didn't want to throw it away quite yet. The big caveat to that is it has to be a commit, right? If you've made changes and you haven't committed them and you've done one of these resets, then it's probably going to be gone if you said hard, because hard just takes everything away that's not a commit. So better to commit than not. Better to commit and make a mistake and roll back from it than not, because at least it's in a commit somewhere, and you can the commits don't go anywhere. They're there. You've got ref log if you want to go back and look and see where you were before. If you lose your shell terminal session history. So there are ways to get back as long as as long as you've got a commit somewhere in your repo. You can figure out, or you can get somebody to help you figure out. But it's there. That's I really want to highlight that, because it helps you try things. And sometimes you just need to try things and get comfortable with it. You just practice with it. And knowing that it's there and it's not going anywhere is really helpful in that respect. So that's git reset -- hard. Let's touch on the other ones. So hard modifies all three of those trees. There's mixed, which modifies two of them, kind of working back from the workspace back, going back one place. Let's see. So suppose. So let's work with this excellent commit here. Suppose we don't want to throw it all away. We just want to go back and have it so, like, just before we commit it, it's still there, but it's not committed yet. We want to just make it better, right? So what we can do here is use reset again, and let's just say we did this. So we didn't use -- hard. So default, if you don't use hard, is mixed. Let's see what mixed does. Okay. Status. Okay, so what happened? So we're unstaged. That's the commit. Let's look at ADOG for a minute. Oh, interesting. So it actually walked back that branch. Right, that's what reset hard does too. So we're back one commit, but we've also got changes now. So what it did was basically, you think of this head, that we moved the head back, and we also moved these index back, but our workspace stayed the same. So now this change shows up. It shows up as a change now. So it didn't change our workspace. It just changed the head and the index. And so now, since this is the same, now our diff shows up as something there. So
that's because we switched branches.
Well, we moved the branch.
We moved the branch.
Yeah. So we moved the branch, and we moved head. So those two went back, and the index went back with it. But our workspace stayed the same. So now we can edit the test and say, you know what, this is what I meant to do, something like this, right? And then we can redo the commit, right? So let's do that. Let's see. Okay, so there's our excellent commit again. Not that again. Oh, but I haven't added it. Never mind. Here we go. So of course the commit SHA is different because not only have I changed the content, I've changed the date and changed the comment itself. So it's a different SHA. So suppose I say, well, you know what? That still doesn't quite hit the nail on the head. Let me try it again. So a reset. Well, now this time I'm going to use the soft option. Guesses of what the soft option does? So hard changed everything. Mixed changed the well. There's head, index, and workspace is what we're working with.
Yeah.
So hard changed head, index, and workspace. Mixed change head and index.
Soft is going to change just index.
Soft will change just the head. Yeah, because we're working backward. So what will it look like then? If I have those and then I just move head back, what will my status show? If index and workspace will change.
They haven't changed. They want nothing to change. No changes have been made to the index or the.
Right. So that's true. But how will that be reflected when I say get status?
Red. Say that you have a that's ready. Stage.
Okay. So when we said -- mixed, we saw red, right? But we saw that. Okay, you've got changes that have not been staged. Now we're saying, okay, we're leaving both of those alone, just changing the head. So there are changes. There are different. A get diff -- stage will show this difference. A get diff will say, okay, there's no difference at all because we didn't change index or workspace. So let's see what that looks like. So status. So again, we moved the head back. We didn't touch our workspace. So workspace is the same, but now also our index is also untouched. So now we've got it ready to commit. So how would this be useful? What sort of scenario can you imagine this being something that you would find handy? Aside from an academic code platoon late morning exercise.
maybe you just don't know where you're at. You just need to get back to maybe you're just trying to find where you're at or something like that. Navigate.
Okay.
So this is like you're about to submit your work one level higher, and maybe you submitted something wrong. You could come here and modify it and do that process again.
Yeah. Yeah. You're like most of what you were going to commit is still good. Maybe you're doing a refactoring and there's 500 files, right? And you committed them and you're like, oh, I forgot one, right? But and maybe these 500 files are you had to carefully pick them out of other files you didn't want to change. Maybe there's stuff that you don't want to actually commit, right? If you go all the way back and you change the index, then you kind of lose. Then all the stuff that was modified now gets interleaved in with all the stuff that really should be in the index, and you've got to go do that work again and push them all back into the index. This way, you can say just bring it to the index. I want to add one more file, or maybe I want to tweak one file here. Leave all this other stuff alone because I don't want to deal with it right now because it's just in my workspace. I know it's showing diffs and whatnot. It's not committed. Just leave it alone. But this index is good except for this one small thing that I want to fix up. Maybe I made a syntax error, right? And I don't want to have another commit because that clutters up your history if you got all these commits.
So basically, you just like that would be the equivalent of just kind of like appending it to that array position, or just like putting up an index on the end of the array. Yeah,
an index can reflect work that you've done, right? I mean, sometimes you just say get add dot and then just everything goes into the index, but sometimes you want to say get add this, get add this, get add this, and you may have a bunch of files and only half of them or some small percentage of them actually go into the index. But that represents work you've taken to choose those files that are going to go. Maybe you need to think about your workflow if that happens too often, but there's work there, and this recognizes the fact that you've done work to prepare this index. And so if you go back and bring what you've committed back into the index by doing a git reset soft, you're not losing that index preparation work that you did before. You're still keeping it there, and you're just tweaking it just whatever it needs to be fully good. So that's one case where, on small projects that may not be an issue, but you won't always be on small projects. So that's the soft. So hard changes everything. Mixed changes 2 of them. Yes, mixed changes 2 of them, and then soft only changes the head and leaves alone the index and the workspace. I mean, just I really use hard more. I don't use the other 2 very much. I know that I could.
I thought it'd be the other way around. Like I thought it'd be soft would be the most useful because it. But I mean,
if my needs are pretty specialized. If I've got large numbers of files, that would very well be the other way around.
Yeah, but I don't either. I think I thought about it wrong. Backwards, but I don't.
Mostly, I make a wrong commit. I want to throw it away. I want to say, you know what, that merge was terrible. Let me start over, right? That's a very common use case. I've got all these conflicts. I did them wrong. Let me just start over. I lost my way. I forgot what was head and what was master and what was where. Let me just go back. And so that's reset -- hard. All right, let me pause. Any questions? Anything I haven't covered that you have wondered about Git that you hoped I would have got to by now?
I've got a really basic question that maybe
Sure.
can help everybody, like including myself, clarify things. If you go back to ADOG,
Okay.
how are they? Just that little diagram over there to the left. Can you just kind of like break that down,
Like this here?
Like
Yes.
retriever?
That's an excellent question. So what that diagram represents is branches. It represents the parent. It basically stitches the parents together of every branch that it finds in refs heads, refs remotes, you know, and the head, of course. And it just follows those parent commits back to draw this diagram. So in this case, this commit is a merge commit because it has more than one parent. It's got two parents. Let's actually grab that and look at it and convince ourselves of that. So if you do a git cat file -p on that guy, oh look, it doesn't have just one parent, it's got two. So that is how it draws that graph, is looking at the parent records in each commit. So that implies that there used to be a branch out here that got merged here, or maybe the branch was here and got merged here. You can't really tell unless you sort of look at the comments offhand. You know, and for a while, this branch got worked on. So if you follow the lines, you can see what the trajectory of this branch was. The branch was probably started here, right here, and then none of these are relevant, but on this particular branch in the green, this one was the next commit, and there was one more commit, and then it was merged over here. Right, that's what this is telling you. So the stars along this path, there's only 2 stars and then a merge, basically, from the time that the branch was created down here. The purple path, you know, it had these 2 commits, right? Because this is where these stars are. So the stars represent commits on that branch path. And then it was merged, right? Some bug fix. And then along here, you know, this is sort of because we've got, you know, this is where our head is. That's what this graph is with respect to, is our head. So that's where the commits are for these stars. Now the content gets there because we merged, right? That's what a merge does. So whatever this stuff was, because we merged, has in some way, shape, or form gotten into this place here. But you know, it came from different commits, which is represented by those multiple parents. Does that help, Aaron?
Yes.
Yeah, that's good. Great question. And yeah, so those graphs can get arbitrarily complex. I try not to make mine too complex, but yeah. So that's I think that's as far as we can get today. Next time, I think a couple weeks, 2 Tuesdays from now, I believe, we'll start to use some git workflow commands. We'll still be mostly local. I won't do much with git pushing. We'll talk about it a little bit, pushing, pulling, and merging. But there are ways that you can sort of take changes and bring them from wherever they are into your local branch. It's handy sometimes. It's called cherry pick. Kind of a subset of merging. If you don't want the whole branch history, you just want that one thing that you like, maybe some bug fix you made that is all embodied in one commit that also belongs on your master, and you just want to do it the simple way. That comes in handy. There's something called Rebase, which can clean up your history before you go and share it with everybody else. So if you've got a bunch of commits and maybe 10 commits that say syntax error, typo, formatting, all the stuff that nobody cares about, you can squash those together and turn it into something that means something to a person who's looking to see what happened with your code. Because once you've got, you know, there's sort of private changes that you don't really care about recording in history. So Rebase helps you sort of rewrite your own history and then share it in a way that's palatable for the rest of your team. Then there's also something called git stash, which you could probably go ahead and play with, which is if you have changes and you suddenly need to go to some other branch, you can just use this sort of scratch area.
It's kind of like a stage, but you stash it for another branch.
You can just stash it for anything you want. Yeah. So if I make a change, right, I've got changes here. and suddenly I'm like, you know what? I need to go to that arbitrary branch, and I say git checkout arbitrary. It says no, you can't because you've got changes, and maybe you've got 100 changes, and you're like, ah. So just say git stash, okay, and then now you can go check out. Then you can go back. So, you know, I think I was on master. Well, I was on excellent. Right. Now you can say git stash pop. Now they're back. Changes are. I got back where I was. So git stash is like a stack. Every time I say git stash, I'm pushing onto a stack of these changes.
So when you did a git stash and then moved into the arbitrary branch, if you were to do git status right after, would there be in there?
No.
So that's two separate things.
Right. So if I do a git stash, right, and actually I think you can see it at ADOG here. Right. So it shows it actually turns that into a sort of commit, so it can keep track of it. But then I can do a checkout to this arbitrary branch. And if I do a git status, you know, I'm just on that branch. My changes are they're stashed. They're off in this stack.
So when you pop the stash, it has to be in its original place where you stashed it.
No, I can do it here. I mean, I can bring them over here. I might cause problems because the changes might not be compatible with what I've got in that branch I've gone to. So you have to you know, resolve that. But you can pop them onto any place you're at.
Seems like we got a lot of playing around with this thing to do for the next 2 weeks. So that'll bless your life. Yeah. So I'm on Slack, so you know, feel free to Slack anytime. Got anything want to ask about or do or try? I'll be available, and then yeah, a couple Tuesdays from now I'll be back here to talk more about these other workflow commands. So that's all I got today.
Thanks, Chris.
Cool.
Thank you.
Thanks for listening.